But sometimes you'll notice those funny shapes, it's easier to do right minus left. So I want to give you one of those. If you got your problem set, just look at number 6. I want to give you something like that. So that's what we're going to, for the rest of class, we're going to kind of hit on this kind of scenario. Which way should I do it? And we're going to make a choice. You know, sometimes it's easier dx dy, sometimes it's either dy dx, or sometimes it's easier either way. It doesn't make a big difference. And you can never split these up, right? I have to do everything iterated in these circuits. So I'm going to do one like that. Here's your bounded region. Oh, this is like number 6. So how about this? Can you do the integral of y? This is d. Ah, it says dA. So they're giving you an option. dx dy or dy dx. D is bounded by x equals y squared. And I'm going to change it up. How about x equal to 18 minus 1? I think the problem's had an 8. Be careful with that drawing. Be careful with the drawing. This guy, I just recently gave a test in Calc 2, and the drawing got people when they draw these. Those aren't functions, are they? But they're curves, right? What's this curve look like? It doesn't look like this, right? One of these dudes. Well, then what's 18 minus y squared? Because it's negative? That's going to make it go up the 18 notches and shift this way, right? But it's the entire parabola. So what would this look like? Where is x equal to y squared? But this guy went what? 18 notches this way, and then opened up what? This way. Extend that x-axis. And I want you to make a decision on this. That's why our sketch was so important. These are going to meet somewhere. I have no idea where they're meeting. You're going to help me out with that. But then we got to make a choice of dx dy or dy dx. It's not a perfect drawing, but it's good enough. X-axis, y-axis. This side is the what? X equals 18 minus y squared. This side was the x equals y squared. And we got to come up with the double integral of y over that region D. This is D right here. The big error made by my Calc 2 students I was saying was they only thought to do first quadrant. It's like, no, the whole region D, bounded by those two curves. So what do you think is going to be easier? dx dy or dy dx? Dx dy should be easier. You go why? If we do dy dx, I want you to study it carefully. From here to here, who's the top and bottom? That's the top, that's the bottom. What happens when you get past here? The top and bottom change, bless you. So you would have to set up 2 separate double integrals and add them together. But if you're looking at it this way, okay, turn your head or turn the view. If you look at it this way, who's the entire top? That dude. And who's the entire bottom over that region? This one I only have to do 1 integral. So I really highly recommend with this problem, let's do dx dy. I'm like, okay, I'm going to do dx dy. This just stays y. And I'm stuck. I need numbers. These have to be y values. I have no idea what they are. So what's the math method where you find where two curves intersect each other?
You set them equal.
Set them equal to each other. Let's do that. So I'm going to do some algebra and see what's my limits. So I can fix this. What is 18 minus y squared equal y squared? Okay, where does 18 equal 2y squared? Okay, where does 9 equal y squared? What's two values?
Plus minus 3.
You got it. Now, if you want to make your picture a little better, that's a -3. That's a +3. And not stuck anymore. These are my y values. Now, I want to make sure you get these limits right. Which equation goes there? And which equation goes here? Remember right minus left? So you can get the neck cramp. Which one's on the right?
18 minus this guy.
There you go, and the bottom left. Right? Left. Right? Left. Guess what would happen if I had to switch around? You would get negative what the actual answer is. Right? Hey, some answers can be negative though. I want to point that out. Don't freak out. You can get negative answers for double integrals. Just like you got negative answers for single integrals. It's like a net volume or net area. Like we did in Calc 1, net volume. Or you could get a 0. But when I can't split this up, so I was wondering if you could work this with me. Because I have no idea what this is going to come out to be. Just looking at this going, alright, what are we going to do? What's the interval y respect to x?
Yx.
Okay, x, y. Now what do I got to substitute into the x?
18y minus y squared.
I'm going to plug that into x, then plug this into x, right? And keep that little y next to it. So I get 18 minus y squared times that y, subtract y squared times the y. Which is now what? And I'll carry this down. What is all that? 18y minus y cubed
Minus y cubed.
minus y cubed. Or 18y minus 1.
2y cubed.
And what's my limits? I carry down. Now I know this answer. And I bet you some people in this class know this answer without even doing the math. Do you recall odd functions? See, we got it down to a single integral. And I notice that's an odd expression. See the odd powers? And I know something funny happens on integrals when you do a negative to a positive of the same value over an odd region. I'll give you an example, like x cubed. Like x cubed is odd, right? They call it an odd function. What happens when you go from like there to there at a single interval? Guess what you get? I bet you we get 0. Well, let's see. Let's play it out. 18y squared over 2 minus 2y to the fourth over 4, but I think we're going to get 0, aren't we? Because we got it down to that center interval. Let's see what we get. 9 times 3 is squared is 81 minus 81 over 2 minus, yep, 81. Just like we thought. What do you get? See it? Let's see it, 0. We evaluated that out. So what's that saying? This is a plane. That's not a, like, one of those like paraboloids or anything. Paraboloid here would be like x squared plus y squared. What would a sphere be here? Right? Oh, x squared plus y squared plus z. And you go, wait a minute. So it's got that z squared, right? They'd have to solve, like, do a hemisphere. That's how you'd have to treat the problem. And I bet you some of you know how to deal with that. You got x squared plus y squared plus z squared equals 4. You can solve for the z. Well, what's going on here with this plane? It looks like over that region, half the plane was what? Half the, over that region, plane was above for half the region, then the other half of the region, it was what? Below the xy plane. That's exactly what's happening. We could look at that with software. That's what you'd see. You'd see it like kind of sliced right through the middle of this. Right? And you came down this way and it's giving that double integral to come out to be a 0, answer is 0. Hey, cool. Okay, let's look at another one where you get to make the decision. You get to make the choice. Do I have it like this on the practice set? If not, I can tell you because where I'm getting from the textbook. No. Well, boy, I'm upset. I thought that these would be more like this somewhere. Oh, nah. Anyway, though, I'm going to take this from section 15.3, but this is like number 22, but this is like number 19. So these are the problems I'm taking. It's in 15.3, but it's something like 19, it's something like number 22. They give you a setup, they talk about D, and you're going to make the decision how you want to set it up. And heck, maybe either way is fine. So what you got to do, when you estimate, or excuse me, evaluate, estimate would be a Riemann sum. Evaluate. Double integral x. Oh, and they put dA here. And then they put a D down here for that region of integration. Where D is the triangular region. With vertices, 0, 0, 2, 2, and 4, 0. Oh, hang on, 0, 4. This is like number 19 and 22 out of the textbook. You can estimate this. This again, we're estimating net volume, right? Let's make that picture, and then we're all going to make a decision on how to handle this. So draw that. 0, 0. I think the hardest part is plotting these correctly. Where's 2, 2? Well, that is that point. Where is that? Over here, over here. That's maybe the biggest. That's where the biggest error can occur during a test. We accidentally plot the point in the wrong spot because they made us plot the points. Where is 0, 4? That's over on the y-axis. Don't we agree?
Mm-hmm.
There you go. Shade it in. The triangle. And a triangle is a general region. So I might as well add it to this image. Triangles are general regions. That means you can't split it up. You're going to have to do it as an iterated interval. The only time I can split it up is if it's a rectangle and everything can be written as a product of x and y's.
Could you do this as the full rectangle and divide by 2?
Great question. If you had knowledge of this surface being consistent over that whole, like a flat roof, that would work. So that's the thing, we're in Calc 3 now, everyone. And I love the way you think. Like, let's take the quickest way to a solution. But now we got a surface involved, like a rooftop. And if it's totally flat, that works. But if it's what? Slanted one way or the other, then we can't do that. So I'm going to treat it as we have, I know it says z equals x there, but we're going to have to do this whole problem because we can't assume that's going to be consistent over the whole thing in terms of taking a rectangle and divide by 2. Great question. You want to do dy dx, dx dy? Here's my decision. I'm going to do dy dx. The reason? From here to here, who's the top, who's the bottom? Look at it. Who's the top was always this, the bottom was that, right? If you do dx dy, turn your head or turn your piece of paper. Doesn't it switch? So if you do dx dy, you're going to need 2 double integrals set up. You're going to have to sum the 2. You're going to do one from there to there, top over bottom. Then add it to here, top over bottom. Do you follow me? So when I'm making my decision here, I'm definitely doing dy dx because I don't want to do 2 double integrals. I just want to do what? 1. So I'm going, all right. There I go. Double integral dy, the dx. This is just an x. Now let's start with the easy stuff. These have to be numbers. They have to be values. So what's the outer limit for x?
0 and 2.
0 to 2. Very good. See? Those have to be numbers, always 2 numbers. But these, it looks like we got equations, and I'm stumped. They didn't give me equations. Oh, by the way, everyone, happens all the time. I get this on the test. Can you tell me why that's wrong? I just built a what? I just built a rectangle. You did too much, right? You did too much. I would be a rectangle. So I always want you to always think. Sometimes people think triangles before numbers. It's like, no. You do that. Anybody know a math way to get these equations? That's all we need. Oh, good. It's 2 points, straight lines. This is Haley, outstanding. All we gotta do is get the equations line, like rise over run and stuff. So the y-intercept, mx plus b, the y-intercept is 0. And the rise run is rise 2, run 2. What's that slope? Y equals x. That's how I got that line. Rise over run, y equals mx plus b. This one, everyone, what's the b value? Y equals mx plus b. The b value is a 4. Do you notice, though, isn't the slope negative?
Mm-hmm.
Okay, good. Slope's going to be negative. Negative rise 2, run 2. So what would be that equation? Good. Negative x plus 4. There's this mx plus b. He said you got a negative 1x for the slope plus the y-intercept of 4. Anyone okay on that stuff? Let's check. Oh yeah, awesome. So that's what I mean. I'm just doing mx plus b. If you have to, feel free to do like, you know, y sub 2 minus y sub 1 over x sub 2, but we can always get the equation of straight lines by just taking those 2 points they gave us. So now, who's here? That's the negative x plus 4. Who's down here? X. Is that what I'm going with? Nice. Well, let's see how this plays out. I know from I could already set it up. Let's move on to another problem. I still think, everyone, today, it's good that you just show me that you know how to do iterated integrals. So what are you integrating this with respect to?
Y,
All right. What's the integral of x with respect to what?
x, y.
Ooh. And you got to substitute a negative x plus 4 and then an x into the y's. So I get x times negative x plus 4. Someone told me 4 minus x. That's probably an easier way to write that. I heard that. That's easier. It looks better too. I'm going to write it that way. I totally agree. When you substitute a 4 minus, it just looks, look, x times 4 minus x minus x times an x, right? Which becomes what? 4x minus x squared, or?
5 minus 2x squared.
And then carry this down. 2x squared, 2x cubed over 3. Becomes 8. Alright, what's 8 minus 16 thirds? What's 24 thirds minus 16 thirds?
8 thirds.
There it is. There's the answer. That's what we evaluate that integral. Hey, every once in a while, guess what you're going to see with some of these problems? You do every problem out of the test. Like every problem, every once in a while you're going to get an integration by parts, right? Every once in a while you get an integration by parts. You remember partial fractions? I don't think you'll see many of those. But every once in a while you get, if you did this every problem out of the book, you get integration by parts. So sometimes you can avoid integration by parts by doing a dx dy versus a dy dx. It's funny. You look at it, look how the problem is. Cool. Hey, nice. Hey, one of the last things I want to do is talk about how we can reverse the order of integration to do an integral. And a good example is like, this is like textbook 15.2. I'll probably even start one like this tomorrow. Page 996, this is problem number 49. Just because I like to give you a lot of practice on this. They call this reverse the order of integration. It's in 15.3. Reversing the order of integration. Why do you want to do that? So I thought I'd give you a problem where it was necessary. Or if we did it one way, our methods that we're knowledgeable of, integration by parts, and u subs, and partial fractions, it wouldn't work. So I'm going to put letter A. Here's the setup. Reverse the order of integration. They've got 0 to 1. 3y to 3. E to the x squared dx dy. By doing it, point out you'd be, told to do this during the test. But you can study it carefully. Why would this be necessary? This would be trouble, wouldn't it? Does anybody know how to integrate e to the x squared? No. E to the x squared with respect to x. Integration by parts doesn't work. U sub doesn't work. Partial fraction doesn't work. Trig substitution doesn't work. You have to go to like a power series method or something to get that thing going. But the whole idea is, man, what if we reverse this? And by reversing, we're talking about take dx dy and change it to what? dy dx. So when we do this, and we're going to reverse this will be letter A, B. This will be letter I. And then how about letter B? Let's evaluate. The double integral, which I can just call the integral. So we're starting out by reversing this. It's hard to just do this by staring. So when I see a student get this wrong on a test, I look for work and I go, now I know why they missed this. I see no picture. We gotta draw a picture, not the surface. That's gonna stay put. We need to draw this region of integration. So can we draw this? Let's draw this thing. What does that look like? Make a really decent drawing. Alright, start out. These numbers, are they y's or x's? And I marked this thing up when I think to do this thing. Let's mark this up. Are these y's or x's? So they're y. So I'm like, okay, your y equals 0. And your y equals 1. I start marking this thing up. Your y equals 0. Your y equals 1. What are these? Oh, your x, and this is an equation. You're a curve. And your x equals 3. That's a line. What I need you to do is shade the region between these two curves. I need this shade between here, and how far? I'm going to put the word from this value to that value. I'm marking this thing up. I need you to go in here, and because I don't want you to shade the wrong region. And I'm going to mark this thing up. I need to shade between x equals 3. What does that look like?
Straight line.
That's a straight vertical line. You need to shade between that line and that's another line, by the way, x equals 3y. Shade between them, but how far? Go from y equals 0 to y equals 1. So when this is my, remember right and left? Because dx what? You're my right side and you're my left side. You agree? So I heard it. On the right, you got x equal to 3. Now what's this? Everyone x equals 3y on the left. I'll go to the left.
So y
I think it's easier if I solve for y. What would y equal?
x over 3.
Yeah, 1/3 x, so I can see the rise run. The rise run, rise 1, run 3, and it goes from the origin, right? So in rise 1, run 3, and eventually you're going to hit that nice line. There you go. There's my left, you're my right. See that? You're on the right side, you're on the left side. Right side, left side, shade between the right side and left side. So where am I shading? Oh, and they said go from y equals 0 to y equals 1. So this is the big dilemma. Do I shade in here or in here? Shade between these. Shade between that and that. Everyone see where you're shading? Does everyone agree? Alright. So I just want, it's so important, I don't want you to be shading the wrong region. Like, man, why did I miss this problem? You shaded over here by accident. What happened? We think who's right, who's left, shade between. So there it is. Now let's reverse this. What do you get? Does this get reversed? No. That stays what? E dx squared. But this gets reversed. dx dy becomes dy dx. Now, I bet you can do this. What are these? They gotta be numbers. They gotta be x values, and they gotta be numbers. The outer limits have to be integers. I shouldn't say integers, they can be fractions, they just gotta be numerical. There you go, he's looking at the image. That nice picture you drew is gonna tell you. Go from 0 to 3. Now, is this right, left, or top, bottom? This is top, bottom, because it's dy dx. We're thinking who's on the top. Who's my top equation, who's my bottom y equation? Alright, who's the top equation? It's that funny slanted line, 1/3 x over 3. Oops, sorry about that. X over 3, who's the bottom? Y equals 0. And for the last thing today, I want to please just solve that. Because you know I can't split this up, right? The last thing, we're going to evaluate this. Let's start here. Integrate that with respect to y. So here comes part B. We're now going to solve this. Oh, that's easy. What's the integral of e dx squared with respect to y?
Just multiply to y.
Yeah, look at that. That was easy. And you're going to plug in what for y? A 0 and a something. Go and substitute the x over 3. Substitute the 0, and I get x over 3 e to the x squared. I love zeros. You plug in a 0, you get 0. So, for the final thing today, everyone. How the heck do I do that in? Man, you're good. That was quick. Good eye. They knew you needed use up here. Your eye saw the x squared versus x to the first. Hey, that 1/3, you want to jam that out of here? I don't care. I'll do it. Let's put the 1/3 out here. And then I'm going to do this use up like everyone suggested. Right here. Here. Let u equal x squared. du equals 2x dx, 1/2 du equals x dx. I do want to point out, if you're rusty on u subs, but you get a lot of practice in this chapter. We get a lot of u subs popping up here and there, so. So what am I substituting? The half du replaces the x dx. And I get 1/3 times a half, which is what? 1/3 times a half is 1/6. Integral symbol. The x dx got replaced by just a du. And what's this become? Hey, I'm keeping this blank because these are u values. So I can't write 0 to 3 here. You can leave them blank, resubstitute, and then put the numbers 0 and 3 back in. Does anybody like to change the limits of integration? I'm looking around. No, oh, no one does, so I'm not going to do it. But I could have changed these. All I'd have to do is substitute a 0 and 3 into what? Like, what's 0 squared? 0. What's 3 squared? None. So if you like to do that, great. But I saw a lot of people go, no, I wait. So I'm gonna what's the integral of e to u? The integral of e to u is
E to the u.
e to the u. And now put your u back. I heard everyone say wait and just resubstitute and go from 0 to 3. So what's this answer?
E to the power
1/6. I'll put a parentheses.
E to
E to
the
the 9th.
-1.
Good. E to the 0 is just a. You just leave it like that on your problem sets or your tests. The one I have in a practice set, there's one like that. That would have a great evening. Super job. We'll do some more of those. I don't want to leave that like. I don't think one's enough.